Hi everybody, this is section 7.2, Proportion, Properties, and Problem Solving for our Math 211 Geometry, from our Math 211 Geometry textbook. We're going to look at proportions again and more problem solving with proportions in this section. So one of the nice things about proportions is they're not always written exactly the same way. Like I could write a proportion and the person next to me could write a proportion. You could have it written, the problem looks different, using the same numbers but in different places, and you can still get the same answer as long as your crossed products are the same. And here on this slide they just show us 3 different ways we can write a proportion and how to apply it. So if we start off with our original, A over B is equal to C over D. You could write the reciprocal of each, so you could switch the numerators and denominators. Again, your cross products would remain the same, so you would still get the same answer. Or we could start off with A over B, C over D, and then just switch the means. So the B and the C would be switched. Still we get the same answer. Or the bottom one is one where you start with A over B equals C over D, and then you add the numerator to each, or you add the denominator to each numerator. So you would do A plus B divided by B, and C plus D divided by D. So mainly, the 2 we're going to work with are the 2 that are listed on this page. We will typically either use the reciprocal of each or switch the means. We don't always use the third way, but it's good to know it because you may see it sometimes. So if I started off here with 3 over x equals 4 over y, another way to write it would be x over 3 and y over 4. And that's the reciprocal of each ratio. Or we could switch the means, so I could switch my x and my 4 and have 3 over 4 equals x over y. Or the third way is to take and add the denominator to each numerator. So 3 plus x over x and 4 plus y over y, and solve it, and it would work out the same as well. Again, that's not one we typically use that often, but it does work. All right, so here we're starting off with x over 6 equals y over 7. And they want to know what ratio completes the equivalent proportion. And so here our proportion starts off, we have x over y. So if I notice, my y was up here, and then it moved over to where the 6 is. So to make this equivalent, I'm going to put my 6 up there and then keep the 7. So they switched the means to make it an equivalent proportion. All right, so here we're looking at scale models on a map. And we are going to, we know that the scale of the map, because it's given to us, is 2 inches on the map equals 5 miles. We can write that as a ratio, so I could say 2 inches is equal to 5 miles. And then they want to know how many miles correspond to 7 inches. So we can use a proportion to solve this. I have my 7 inches here, so when I set up the other side of my ratio, or my proportion, the other ratio, I'm going to put the 7 inches on top because I want to keep inches together both at the top or both at the bottom, depending on where I put the initial one. And then I'm looking for miles, so that's my unknown. I'm going to put my x there. And then remember, to solve, we'll cross multiply and divide. So 2 times x is 2x. Keep the equal sign. 7 times 5 is 35. And then we're going to divide by 2. So x is going to be 17.5. And you do want to put your unit on there. We were looking for miles. So it would be 17.5 miles. All right, so next we are going to find out the standard dose of antibiotic for a woman who weighs 140 pounds. And based on the medicine's calculations, they know that for every 25 pounds of an adult, they get 4 cc's. So, we can kind of estimate how much medicine the person will need, but to find the exact amount so that we don't give them too little or too much medicine, we're going to use a proportion. So we would say, okay, well, I know that we know there's 4 cc's for every 25 pounds. So I'm going to write that as a ratio. And then I know that my person weighs 140 pounds, and I need to find out the dose of the medicine. So there's my proportion. I'm going to cross multiply. So 4 times 140 gives me 560. And that is equal to 25 times x is 25x. We'll divide by 25. And x is going to equal 22.4, and that will be cc's that is needed for the patient. Okay, next we are going to look at 3 proportion problems. The first one, we have an NBA player who averages 45 baskets for every 100 attempts. If the NBA player attempted 800 baskets, how many baskets did he make? So we know initially he can make, or there's an average of 45 baskets for every 100 attempts. And then we want to know if they attempted 800 baskets. So 100 is my basket, so I'm going to put the 800 on the bottom, and then my x. So when I go to solve this, I'll have 100x is equal to 36,000. Divide by 100. And x is going to be 360 baskets. Right now for the next one, on average it takes a gem cutter 90 minutes to map the cutting of 4 gems. So we know right now our initial ratio is 90 minutes over 4 gems. And then how long does it take her to map the cutting of 22 gems? So the 22, 4 is my number of gems, so the 22 is going to go on the bottom, and x will on the top because we're going to find out the number of minutes. So when we cross multiply, we will have 4x is equal to 90 times 22 is 1,980. Divide by 4, and we're going to get x is equal to 495, and that will be minutes because that's what we were missing. Now the next one, it says find how many gems she can draw maps for in 4.5 hours. So again, we have our initial ratio of 90 minutes over 4 gems. And the one thing to pay attention to here is they give us 4.5 hours, but our ratio has 90 minutes. So we need to convert 4.5 hours to minutes. So I'm going to take my 4.5 and times it by 60 minutes in an hour, and it gives me 270 minutes. And then we want to find out the number of gems. So now we'll cross multiply. We get 90x is equal to 270 times 4 is 1,080. Then we will divide by 90. And x is going to equal 12 gems. All right, so next we are dealing with some fractions that I know all of you love. We are looking at an architect's blueprint. 1 inch corresponds to 8 feet. Find the length of the wall that is represented by 2 7/8 inches on a blueprint. So if I were to set this up, I know that 1 inch corresponds to 8 feet. And we know that the length on the blueprint is 2 7/8 inches. And we want to find the length of the wall. Now, to properly do this, we don't want to work with a mixed number. We want to turn that into an improper fraction. So remember, take the whole number times the denominator. So 2 times 8 is 16. Add the 7, and we get 23. So I have 1 over 8 is equal to 23 over 8, and that'll be all over x. Then we're going to cross multiply. All right, so when I cross multiply, I end up with 1x, or x, because we don't need to put the 1 there, is equal to 8 times 23 over 8. And again, make that over a 1. So our 8s can cancel out. They equal a 1 when we cross simplify. So my answer is going to be 23 feet. For my next one, we're going to start off again with 1 inch is equal to 8 feet over 5 1/4 inches over x. Now when I turn 5 1/4 inches into an improper fraction, 5 times 4 is 20 plus 1, so it's going to be 21 over 4 over x. So when we cross multiply, we'll get x equals, and so then we get 8 over 1 times 21 over 4. And again, I can cross simplify. So my 4, I'm going to divide by 4. So 4 goes into 4 once, and the 8 will become a 2 because 4 goes into 8 twice. And then I only have to multiply 2 times 21, and I end up with 42 feet for my final answer. All right, and for our last problem, we know that the Trump World Tower in New York City is 881 feet tall, and it contains 72 stories. So the information I know there is to set up my proportion. I know it's 881 feet tall and 72 stories. And then the Empire State Building contains 102 stories and has the same number of feet per floor. Approximate its height to the nearest foot. So what we're going to do is we have 102 stories. My 72 is there. So I'm going to put my 102 right there and my x. Cross multiply. So I'm going to have 72x is equal to, when I do 881 times 102, I get 89,862. And then next we're going to divide by 72. And when I do this, I end up with x equaling 1,248, and there's quite a decimal afterwards, but I'm going to put to 800ths, although they ask to the nearest foot, so it's approximately 1,248 feet tall.